You're doing perfectly good. So, in this part, we'll be discussing about the chemical properties of alcohols. Have you ever wondered whether an alcohol is acidic in nature, a phenol is an acidic in nature? Have you ever wondered what happens when an alcohol reacts with the metal? Have you ever wondered what happens when an alcohol reacts with the Grignard reagent? The answers for all these questions we'll be understanding in this part. So, we'll be discussing about the chemical properties of your alcohols, phenols and ethers. So, let's start with this part. Chemical properties of alcohols. So, first let's discuss about acidity of alcohol. Alcohol is weakly acidic in nature. So, in aqueous solution, alcohol will donate its proton to water molecule to give an alkoxide ion, that is nothing but RO minus. So, you can see here ROH in water, in aqueous solution it donates H plus, and because of this it has an acidic property. Even though it is weakly acidic in nature, it has an acidic property. So, it is an alkoxide ion. So, you can see here ethyl alcohol, and in aqueous solution you will get CH3CH2O minus, and that H plus will be getting attached to H2O to form H3O plus. So, the acid dissociation constant Ka of an alcohol is defined by the equilibrium, and yes, ROH and H2O, RO minus H3O plus. So, if you consider an equilibrium, if you consider this as an equilibrium reaction, that means you can have a equilibrium constant. So, here that equilibrium constant will be acid dissociation constant, since we are discussing about an acidic nature of an alcohol. So, it will be Ka into products, the concentration of the products, which is nothing at H3O plus RO minus by ROH, and pKa will be minus log Ka. So, you already know that smaller the value of pKa, the alcohol is more acidic. So, effects on acidity of alcohols. So, the acidity decreases as the substitution on the alkyl group increases. So, ethyl group is electron donating group. So, it strengthens the OH bond. If it strengthens the OH bond, always remember it is always hard to release a proton. Remember an important concept, whenever you have OH bond, right, weaker is the OH bond, higher is the capacity of the OH to release hydrogen. That means its acidic nature increases. But if the OH bond strengthens, it is very hard to release a proton. So methanol is more acidic than obviously tertiary butyl alcohol. So, it is now clear that, for example, now you have OH. So, if you have OH, if you have a withdrawing group, it weakens the OH bond, so acidic nature increases. So, any atom or any molecule which has electron withdrawing capacity, that means it increases the acidity of alcohols. So, the electron withdrawing atom enhances the acidity of alcohols. So, the electron withdrawing atom helps to stabilize the alkoxide ion. For example, you have 2-chloroethanol. So, 2-chloroethanol is more acidic than ethanol. Alcohol with more than one electron withdraws atoms are more acidic. For example, you have 2,2-dichloroethanol. Obviously, now you have 2 withdrawing atoms, right? You already know that if it is a 1 withdrawing atom only, your acidic nature was increasing. Now, instead of 1, you have 2 withdrawing atoms, that means your acidic nature again increases. So, 2-chloroethanol, 2,2-dichloroethanol is more acidic than 2-chloroethanol. So, chemical properties of alcohol. So, what happens when alcohol reacts with the metal? So, alcohols react with the metal. So, for example, if the metal is sodium, you will get an alkoxide and you will get hydrogen. So, alcohols reacts with metals to liberate hydrogen gas. So, you can see the liberation of hydrogen gas here. So, this is an important property of an alcohol. Formation of halides. So an alcohol can be converted into halide. How? You can add iodine. For example, you are adding iodine, it converts into an alkyl halide. But remember here, phosphorus eases the reaction of alcohol with iodine. So addition of phosphorus is very important in this reaction of formation of halides. So your alcohols reacts with other reagents like SOCl2, PCl3, PCl5 to get an halide, alkyl halide. So even though you have an alcohols reacts with HCl, I mean any halogen acids to give your alkyl halide. So alcohols reacts with even sodium bromide in presence of H2SO4, you will get alkyl bromide. Alcohols reacts with HCl, the same thing. If it is in place of X, it is Cl, you will get an alkyl halide. Reaction with HNO3. What happens? An alcohol reacts with HNO3. Whenever alcohols react with HNO3, you will get RONO2. This is important, right? Because your H2O will be removed and the remaining is NO2. This NO2 gets added to the oxygen atom in the alcohol. So you will get RONO2. Reaction with carboxylic acid. This is a esterification process where an alcohol reacts with acid. In acidic medium, you will get an ester. So alcohols can be converted into esters. So order of reactivity of alcohols, your 1 degree, your CS3OH is reactive than 1 degree alcohol, then greater than 2 degree alcohol, then 3 degree alcohol. So I can say that 3 degree alcohols are less reactive than your 1 degree alcohols. So reaction with Grignard reagent, your alcohols react with Grignard reagent RMGX, and you can see that you can get an alkane RH, right? So this is an important process where alcohols can be converted into alkanes. Reduction of alcohol, even not only this, there is another important process where you can convert your alcohol into an alkane. You have to reduce it, and in presence of red phosphorus, and you have to use hydrogen iodide, and you will get an alkane. So these two examples are the examples where you can convert your alcohols to alkanes. Dehydration of alcohol. So dehydration of alcohols takes place in acidic medium. Dehydration is nothing but removal of your water molecule. So dehydration of alcohols takes place in acidic medium. So intramolecular dehydration leads to the formation of alkene, while intermolecular dehydration forms ether. So ease of dehydration, tertiary, it is for tertiary greater than secondary greater than primary. Why? Because in dehydration the intermediate step is the formation of carbocation, and you know that tertiary carbocation is more stable than secondary, and secondary is more than primary. So Sedgwick's rule, more substituted alcohol is formed as a major product. Yes, because again the same thing, more substituted before the formation of alkene. If you are more substituted groups, that means your stability of carbocation increases. So you can see here, so you have concentrated H2SO4, and you have two chances. One is major, you have the possibility of 2-butene and the possibility of 1-butene, but 2-butene is more, it is present in higher quantity because you, according to Sedgwick's rule, more substituted alkene is formed as a major product. So oxidation of alcohols, just like aldehydes can be oxidized, even alcohols can be oxidized. So aldehydes get oxidized to form your carboxylic acids. So similarly alcohols get oxidized to form your aldehydes. So further oxidation converts into acid. So you have ethanol, ethanol gets oxidized to first to acetaldehyde hydride, then removal of water molecule takes place, then you will get acetaldehyde, and acetaldehyde, and if you have acetaldehyde hydrate here itself, you oxidize it further, you will get acetic acid. Haloform reaction, right? Haloform reaction is a very important reaction which is a test for your ketones, and not only ketones, for ethyl alcohol. So ethyl alcohol and 2-degree methyl alcohol gives me a haloform reaction. So according to haloform reaction, you have an alcohol, that alcohol reacts with iodine and NaOH, you will get CHI3 and you will get an acid. So the important process is you can convert an alcohol into an acid, right, in addition to the formation of iodoform. This is called an iodoform. So this is the mechanism here. First you will be adding iodide and NaOH, and that helps to convert into your aldehyde, and further what happens is you have Ci3 here, 3 iodines get attached here, then again your OH gets added here, then you will get Ci3 and you have H already, that converts into CHI3 and your acetate ion. Test for alcohols. So these are the important tests for alcohols. One is Lucas reagent, one is Victor Mayer test. So whenever you are using Lucas reagent, 1-degree alcohols, they show no reaction at room temperature. 1-degree alcohols, they show no reaction at room temperature. So if you are having a 2-degree alcohol or 3-degree alcohols, you will get white turbidity. You will get a white turbidity. For example, if you have a 2-degree alcohol, you will get white turbidity after 5 to 10 minutes. But if you have a tertiary alcohol, you get white turbidity instantaneously or instantly. Not only that, Victor Mayer's test. So 1-degree alcohols red color, 2-degree alcohols blue color, and 3-degree alcohols are colorless. Chemical properties of phenol. So acidity of phenols. So just like alcohols are acidic in nature, even phenols can be acidic in nature. Why? Because even phenols have the hydrogen attached to oxygen which can be removed. So phenols are more acidic than water and alcohols due to resonance stabilization of phenoxide ion. There also you are getting alkoxide ion whenever you have an alcohol, but you are getting a phenoxide ion. But this phenoxide ion is more stable, so because of it's a resonance stabilized. So if the phenoxide ion is more resonance stabilized, that's why your phenol is more acidic than your alcohol. So decrease in electron density in oxygen by more electronegative sp2 carbon in phenoxide ion. This is also one of the reason. So you can see that once you lose H plus, you will get a phenoxide. So this phenoxide ion is a resonance stabilized. So these are the possible resonance structures which actually increases the stability of phenoxide ion. So higher is the stability of the phenoxide ion, higher is the formation ability of this phenoxide ion, higher is the formation ability of this phenoxide ion, higher is the acidic nature. So this is an sp2 carbon. So stability of conjugate base is more as compared to your RO minus. Comparing acidity of alcohol, phenol and water. Alcohols react with water, the same thing, you will get RO minus and H3O, but your Ka value is 10 power minus 16 to 10 power minus 18. So the negative charge is confined to oxygen and it is not spread over the alkyl group. It makes RO ion less stable. But in phenol, you have Ka value of 1.2 into 10 power minus 10. Here, you have the negative charge on the oxygen in your alcohol, right? Even your alcohol has a negative charge, but this negative charge remains on the oxygen itself because there is no possibility of resonance. So this negative charge is confined to the oxygen and it is not spread over the alkyl group. So that's why it makes RO ion less stable. Next you have phenol. Phenol gets converted into phenoxide ion, and see the Ka value is higher. So higher the Ka value, higher is the pH, higher is the acidic nature. So you can see here H2, for example, H2 is also considered to be acid, but it is still the K value is 1.8 into 10 power minus 16. So you can see the K value is higher for this. First chemical reaction of your phenol acylation, where if I have a phenol and I have an acid chloride, that gets converted into phenyl ester. So this is an acylation property where you can convert an alcohol into an ester, which is a phenyl ester. Displacement of OH group. For example, you have alcohol. That alcohol, for example, reacts with zinc dust to give an alkane. This is a famous important reaction. For example, you have phenol. That phenol can be converted into benzene using zinc dust because you are displacing your OH group. So I can say that if you have a phenol and if you have zinc dust, you can convert that into benzene. Next, hydrogenation. If you have phenyl alcohol, I can hydrogenate it, I'll get cyclohexanol. Oxidation to quinones. So phenols can be oxidized to quinones. Mercuration. You have a phenol. That phenol can be converted. That phenol, when I actually use a mercuration reagent, for example, here it's a mercuric acetate, that gets converted into, you can add iodine at the end of the process. So iodine can be added. So the intermediate process is your mercuration process, and afterwards I use NaCl, AgNaCl, that converts this into AHgCl. Finally, I can use iodine in presence of CaCl3 to get iodine. So reaction with zinc dust, I already told you, whenever you have a zinc dust, that alcohol can be, that phenol can be converted into benzene in presence of zinc dust because I am displacing my OH. Riemann-Tiemann reaction. So this is another important reaction of your phenols. If I have CaCl3 and in basic medium, I can get a salicylaldehyde. This is actually salicylaldehyde. So conversion of phenol into salicylaldehyde is a Riemann-Tiemann reaction. So the first thing is I have CaCl3 and aqueous NaOH. This is the intermediate product, and I have NaOH, and obviously I'll get a phenoxide ion. Then hydrolysis, you'll get an alcohol. So this is an important reaction where I can convert your phenol into a salicylaldehyde. Salicylaldehyde is nothing but you have an aldehyde group and also an alcoholic group on the benzene ring. Cope's reaction. So Cope's reaction is another important reaction where you can convert your phenol into salicylic acid. So you are, instead of aldehyde group, now you have acidic group here. So phenol, you are adding again the basic medium, and you know that whenever you have a basic medium, you have the sodium, you have phenoxide ion. Here if you have sodium phenoxide ion and you have carbon dioxide. So this again, the important thing is in Cope's reaction is you are adding carbon dioxide. So you will get a salicylic acid at the end of the reaction. Chemical properties of ethers. So dehydration with H2SO4 and Al2O3. So when both alkyl groups has beta hydrogen, for example, you have an ether. So whenever you are having concentrated H2SO4, you can get two alkenes here. One is CH2 in this, and CH3 CH and CH3 CH3 in this, and H2 will be removed. So when alkyl group has beta hydrogen, instead of here you have beta hydrogen, but here how many beta hydrogens were present? Here instead of beta hydrogen there was alpha hydrogen was present, but there were two beta hydrogens. But instead of that when one alkyl group has a beta hydrogen, so you will be getting an alkene and also an alcohol. So hot concentrated H2SO4 reacts with secondary and tertiary ethers to give a mixture of alcohols and alkenes. So you can see here ether in presence of concentrated H2SO4, you will get CS32 and CCS2 and you will get an alcohol. So nucleophilic substitution reactions of ethers. So here there are the nucleophilic substitution reaction of ether. Whenever you have concentrated H2SO4, you know that you will get an alcohol. But if you have 2 moles, you will get SO3H gets added in presence of hydrogen and you will get 2 moles of SO3H. Here you got 1 mole of SO3H. And whenever you are adding H2O at higher pressure, you will get an alcohol. So this is how an ether can be converted into alcohol. If you have hydrogen iodide, right, so you will get an alkyl halide and an alcoholic group, right. So this is how ether can be converted into an alkyl halide and an alcohol. So if you have 2 moles of HI, 1 alcohol further reacts to form an alkyl halide. If you have 3 moles, you know that 3 moles an alkyl halide can be reduced to an alkene. So if you have an acid chloride RCOCl and anhydrous ZnCl2, you will get an alkyl chloride, alkyl halide and you will get an ester. And you have RCOCOR, you will get ROCOR and ROCOR, this is again an ester. And if you have PCl5, you will get an alkyl halide, you have 2 moles of alkyl halide. So students, these are the different chemical properties of your alcohols, phenols and ethers. We learned how an alcohol is important and how an alcohol can be converted into your aldehyde, ketone, right. We learned about the important reactions of the phenol. Remember, the important reactions like Riemann-Tiemann reaction of phenol are very important, right. I suggest you to go back and just revise this part once again, and in our next part we will be discussing about the previous IIT-JEE questions. Till then, just keep tuned to our sessions. Take care. Goodbye.